My name is Trek. You can find me on Twitter or GitHub at Trek. I tend to grab that username everywhere. I work on the internal tools financial engineering team at Groupon. And before you think, wow, financial engineering, that's really boring, I'll remind you a financial engineer was cool enough to be the villain in a Superman movie. So I'm at least that cool. I also do consulting with these folks. We've helped companies like Netflix, Mozilla, Square, Zendesk, Live Nation, and others build and optimize sort of big next-generation web applications. We're always looking for new projects, so feel free to hit us up. And I've spent the last 3 years working on a project with these smart folks called Ember.js. Our goal is to have me not have to come in and do consulting. We want to give those tools to you so that you can do them yourself. But there's a lot of work to be done in that. Chief among that work is getting people to understand that the web browser isn't just about documents. And that's sort of what I hope to convince you of today. So if you attended the previous talk, which involved things like click handlers and element selectors, I would like to talk to you about why that is a horrible way to write applications for the web. In the web's short history, the document has been pretty tightly coupled to how we develop for things that we launch in the browser. And I think the browser is a great document viewer, but it has also become something much better. Escaping this document-centric view will help you build applications that are much better and have the sort of client-side interactivity that people come to expect from things like native clients or web applications like Gmail or Facebook. The first cars had all the trappings of a carriage, except for the horse, of course, even when these things weren't suited to a car. So for example, the weird thing in the front, the fact that the top sometimes goes up, sometimes goes down. Cars really sped ahead, pun intended, as a technology when we realized this analogy wasn't useful for the purpose anymore, and we decided to just build cars that themselves were cars. So I think it's pretty easy to see how a document analogy works with a web page like this, but it's much harder to see how this is a document, especially when I tell you the same code that powers that website is also what powers their native client. So, like, what about that is a document? And a question of, like, how did we get here? Like, why is document become the analogy for how we think about building things for the web? A quick history lesson. Sir Tim Berners-Lee, built the web. He dreamed it up and put it on this Next machine. This is the original Next box he used. The little sticky note says, "This machine is a server. Do not power it down." There was a point where you could, in fact, power down the entire internet. And this is what documents meant to him. You can get a good feel for what a document in his mind was when he was building this tool for sharing and authoring documents by looking at the original selectors you had available to you in HTML. They're very much this, without the column layout, of course. So paragraphs, headings, ordered lists. And his goal for the web wasn't building applications, it was building documents. So he wanted to have a place where you could write documents, and he thought that would be done in 6 months, and then also a place where we would have universal authorship and automatic notification of a reader when new material or interest her became available. So he was pretty good estimating on the first one. It took him about 6 months. His estimation on the second one was a little off. So remind that to your boss or any clients when they ask you for solid deadlines. Like, well, whenever Tim Berners-Lee gets universal authorship done, I'll be about a week after that. So documents, surely this, and obviously this. Ignoring column layout, early HTML definitely had all the markup necessary to do a document like this. Maybe a document like this, although there's getting to be some layout that early HTML could not do. And that lack of specific layout kind of puts you in Tim Berners-Lee's head where he was at for what a document was. And to him, a document was a single column. So for example, short line lengths aid in readability, but on the web you get a short line length by resizing your browser, so the line length can be as short or as long as you feel it needs to be to aid in legibility. And before CSS, we definitely didn't have the layout capability to do something like this. And certainly, we could not have come anywhere close to doing a document that looks like this using the tools as they were intended. But given a technology, people will find a way. So here's the early version of Amazon from 1995, using the tools as intended. This is pretty much the best you can do with an image tag, some headers, some lists. Oh, sorry, this is 94. Within 18 months, it looked like this, which I would argue is not at all like a document you have ever seen outside of web documents. Other people followed suit, so here's the early news.com site, ESPN, eBay. So we started to use this for things that were clearly not documents, catalogs, forums, band sites, and then the daddy of them all, the Space Jam site, which is still up to this very day. You can go visit it. It still works. Document is such a poor analogy for what this is that it seems insane to think of it as a document, and yet it's still using the same raw materials that we use to build a newspaper or an academic paper. So how do we turn a few dozen tags for marking up academic papers into this global platform for commerce and work and communication, dating and gaming? Well, we've used the hell out of the technology. So is that animating for you guys? Yes or no? No? Yes? Will it start animating? I can't tell. There we go. So this is eBay, early eBay. And this is how you worked with the web in the early days, because the tools you had at your disposal were so poorly suited to the tasks you wanted to do. Doing this by hand was obviously a nightmare. So we built tools to help us do this, specialized tools for crafting HTML. And then we would have specialized tools for doing visual design and specialized tools for, making Gantt charts or whatever people with MBAs do. And this really fit the primary development model of the time for engineering, which was waterfall. An idea was ideated, designer creates some mock-ups, a front-end developer with a combination of pluck, determination, and spacer gifs created the markup, handed it over to a server developer, a customer would verify, and we were done. And all the tools were pretty much the spec. This is one of the earliest versions of Photoshop that I used, and it was painful to use. I don't think this is the first version that had layers, so that was a huge step forward. These are the dark days of the web that I was around for, and these lasted well into the early 2000s. Things moved along. The browser wars were fought. I would say we lost them. And then something happened. The Sandinistas came out. People like Dan Cederholm, Jeffrey Zeldman, Andy Budd. They really pitched a version of the web that used the technologies as intended to craft documents. A list apart is probably one of the early examples of this that would talk about semantic use of HTML and separating content into HTML, style into CSS, and then slight additional behaviors into JavaScript. It's kind of when the document made a comeback, so there are no font tags, no spacer gifs, still very hard to use. And we had basically had to abandon all of our previous tools. Computers are not great at semantics. They're pretty good at the visual model we had before and not really good at semantics. And this would be okay if really what we wanted was documents, but people were still doing things that were very not document-centric. And that came with some challenges. So how do you do rounded corners for tabs? Not really a document thing, but definitely an application thing. How do you do background gradients? A ton of hacks. How do you do something as simple as, I don't know, vertical centering? Six easy ways to vertically center with CSS. And the real problem here is that we're trying to build applications using a tool that is basically built for content flow and not block or grid layout. So if you take a look at where people are building applications in other environments, you get this nice little auto-sizing stuff, where in Cocoa you could describe the relationship between two elements in a screen, and they shrink and grow as necessary. I mean, how much would you pay for a button in the browser that would make CSS layouts just work? You get that in a place like Cocoa. CSS, we have more something like this. You'll have to tell me when it stops animating. I can't see. That's the world we live in. And this is also the era when many non-programmers, non-engineers were starting to handle important programming tasks in the browser using a decent programming language called JavaScript. And because these people were not engineers, and this is a very weird and poorly understood language, I think we were kind of limited in what we were willing and capable of doing at the time. So if it doesn't use jQuery, you're probably doing it wrong, even if you just need to do math. As a consequence of this, I think a ton of massive talent migrated away from the browser in the mid-2000s and went to proprietary mobile platforms. It's pretty easy to see why. You get all sorts of awesome features for building rich client experiences, file access, location API, video playback, a real layout engine, vector and bitmap drawing, all sorts of stuff. And the browser can even round corners. So Worse, barring a few edge cases, most of these developers were existing server application developers or probably developers entirely new to engineering who skipped the web and went to a proprietary platform. We basically lost an entire generation of solid web developers who went and did mobile. Thankfully, generation on the web is only about 3.5 years, so there's still hope. The story, I think, has massively improved, and we'll soon see wider adoption. So HTML5 gives you a lot of the things that you would expect to have in a full client framework. File access, geolocation, camera access, microphone access, drawing. CSS gives you border styles, gradients, fonts, columns, an actual layout system. So there's a very small grid system in CSS3 using Flex. And then JavaScript is becoming a modern language. We're getting important engineering concepts like promises to better handle asynchronicity, generators, module, real dependency management, and probably most importantly, better performance. So this chart's a little old because it only goes up to probably about 2010, but this shorter bars are better here. This is performance between different browsers with IE8 lagging, and places like Safari and Chrome doing quite well. And that's also within single browser visions. So here it is reversed. Larger bars are better, and this is the improvement just within Chrome itself. So performance is pretty impressive. I'm going to go ahead and skip to a video I want to show. Has anyone ever heard of ASM.js, ASM.js? So ASM.js, ASM.js is a subset of the JavaScript language that as an author you can target, and that will get passed essentially straight down to machine code. So you're effectively capable of compiling JavaScript applications. This is an example of the Unreal Engine running natively in the browser without a plugin. Can you see it or no? Dang, oh, because it's on my window. Well, it's real cool, you just have to trust me. But now I can't. Do I remember the keyboard command for mirroring? Yeah, all right. Let's do this for a while. I'm going along at a, now we can go, all right. Let's go back to the beginning because it's pretty awesome. Again, so this is the Unreal Engine running natively in the browser, no plugins. This is 4, I believe. This is just in Firefox. They've been targeting the ASM stuff pretty heavily. And it's running at about a quarter, maybe a third native performance. And that's just a start, right? Like this is a technology that is still in heavy development. Clearly, this is something that you would not even have thought possible 3, maybe 5 years ago. And yet, this is the stuff available. So this is all using like WebGL and other modern technologies that browsers have. And it's not just for 3D gaming. You can make 2D games in it. And this gives you access to things like the GPU, so you can have really awesome performance, even though you're running in essentially a virtual machine inside your computer, and that virtual machine is the browser. There's some Mozilla folks here. Steve Klabnik is here giving a talk later this afternoon. So you can ask him about that stuff, because it's pretty cool. Not mirroring. Now the question is, will it show you my notes, or is it going to show you the slides? Oh, wow. They fixed that, so it got it right. The browser's also getting awesome debugging tools. Probably, actually, if you've done client development in other environments, better debugging tools than you would find, honestly, anywhere. And these are built-in tools, right? So the Chrome debugger. This is the recording of the rendering process for this site. And you can drill down and see exactly how long things took, figure out what parts of your code are inefficient, and work to fix them. It's also super extensible, so we have custom build tools. This is the Ember inspector, so this is showing the current hierarchy of views on that page. You can also see here's all the possible routes that this application can render. So really powerful tools that are much easier to craft than they were 5 years ago. And the ecosystem is getting better. There are build tools like Bower, dependency management, which is pretty awesome. Not long ago, there was a saying, the web doesn't need a build step. That's what reload is for. But in the intervening years, people have adopted technologies like Sass for managing their CSS. And clearly, there are multiple build steps. You need to compile Sass, concatenate JavaScript files, minimize them. We've been doing this for a long time, and now there are standards emerging of practice around this for doing it more consistently. And shockingly, IE is catching up in a really awesome way. Starting with IE 10, IE has gone evergreen, which means just like Chrome or Firefox, once you're on a modern version of IE, you will always be on the modern version of IE unless you specifically opt out. So I think we're going to be able to get away from the having to support a 10-year-old browser for eternity, which is pretty cool. And a new generation of developers is coming who are never going to learn about the browser as a way of viewing or playing with documents. This is Devaris Brown. He gave a talk last week, a very moving talk at the Ember conference about teaching children in the Tenderloin, which is a sort of underprivileged neighborhood in San Francisco, how to do web development, starting with HTML, moving into CSS, then Ember, and then Rails. For them, that was very approachable. For people who have difficulty dropping the document paradigm and adopting something new, they tend to think that there's just incidental complexity that cannot be escaped. When really, I would argue it's you're moving to a different programming model, and your old skills will not avail you. So if you're buying what I'm selling, what is it actually like to develop in the browser with an application paradigm instead of a document paradigm? Not terribly weird. You're probably already doing a little bit of rendering on the browser anyway, and if you use something like jQuery or Backbone wrapping jQuery or Angular, the separation of concerns or tasks that you need to do probably goes a little bit like this. You need to handle display and screen rendering, screen state, so what should I be showing right now, away from keyboard behavior like triggering emails, and then data persistence to write a web application or basically any client-server application. And likely you've put this line in between the separation of concerns that said, well, screen state, what should I show, is probably the URL you're at. The server should return a particular page. Asynchronous behavior like email processing is very clearly the server. Persistence is very clearly the database. Display is something the browser does. And screen rendering, well, we'll render a bit of the screen and send it down for us. And then afterwards, we'll add additional behavior with JavaScript. So now we're just moving the bar a little bit backwards, I guess this way from your perspective, and saying that the server does server stuff and the client does client stuff. And really that's taking this model where a client speaks directly to APIs on all other platforms except for the web, and turning it into this, which is arguably, I would say, more architecturally consistent and easier to work with. To put it another way, imagine the reverse example we're happening. If I wanted to develop an iOS app and I was worried about actually learning how to do iOS development, I could have a server render up a Cocoa view. That sounds crazy, but does that animate for you or not? I can't see. Too quick? Cocoa views can actually be XML files. They're human readable. I could totally write an OS or iOS app with a lot of hacking that would send down this XML on every click. So every time someone clicks to go somewhere, it would just send them a new Cocoa view, and I would escape the complexity of having to write a client-side application. It would be crazy, and yet this is exactly how we write web applications today. The reason we've hesitated to do that in the browser is the tools pretty much stank, but they're getting better. But only through years of refining has this happened, so we're much closer today. So if you decide document isn't a paradigm for everything you want to do, you're probably going to face two major challenges. The first is going to be leaving behind your old patterns. Writing an application that happens to emit display into the browser is not about selectors. It is not about event triggering. It is much more about taking data and displaying it. So you're going to need to figure out new patterns, and this is the second challenge that you're going to face. Thankfully, there are many new tools to help you do this, so you're not sitting out there going alone, handcrafting frameworks and becoming very, very frustrated, which was the pattern I had to go through for about 3 years when I wanted to do this. Now I just help out on the Ember.js core team. So in the remaining time, I'm going to take you through an example application and show you sort of how this would be architected using Ember.js. It's not dissimilar to how you would probably architect with Angular or Backbone, so although the examples are Ember specific, the knowledge is pretty generalized. So moving a lot of logic into the client will necessitate writing more code in the client. And not just any code. You don't want spaghetti code. You want well-structured and organized code, with each layer having a single responsibility. The structure of an Ember app is actually borrowed from a Smalltalk MVC variant that we stole from Apple, because basically they've been doing this for a long time, and there's no reason to reinvent this, except we have to reinvent it for the web. And each of these layers answers a different question. So the router answers, what's the current context, and how do we encode this into the URL such that the person can share the URL with their friends or return to this later on? The route basically handles what data should I fetch for when I want to display this screen, and then what template should I render it into. The controller translates bare events like click, double click, mouse over into semantic events like show post. And it also handles how do I present data for this context of rendering. View and template, basically how do I paint to the screen and what should I be showing. And then model and data are basically the structure of your data that you've fetched. Everything has a default behavior in Ember, so you will not necessarily need to implement every single one of these as you write your Ember application. So a very simple, probably the simplest Ember application involves only a little bit of JavaScript and only the view template layer. So in the JavaScript, you would just say create a new Ember application. You would have a template that would just say welcome to Ember.js, and it would look something like this. A slightly more interesting example, adding some routing. So this will add a screen called About and one called Favorites, and you can customize the particular URL you would like that screen to live at. The template now has the ability to link between these two states, and something called an outlet, which is basically a region of the screen that we will fill as you navigate into different routes. So the Favorites just shows a list, and the About just says About. And it looks something like this. And as you toggle between the two, you get to see the next route. So this isn't terribly interesting. Most likely you want to fetch some data from some remote server that has long-term persistence and put that into a template. And for us, that's the route. So we're going to use the route object. And here you just implement a model hook. And all you have to return is data, basically. So $Ajax works perfectly well. You don't need a complicated model system. We work very well with plain objects. One thing that may seem weird to you is there's no success callback. So we've adopted promises, which are a technology you can use today, as a better way of handling asynchronicity. So it doesn't look like this, basically, where we need to like store self in a thing, or show the loading page, make an AJAX request, and then the response comes back, hide the loader, and then put some data into a view. That's all being handled for you, so you don't need to write code like this. So some response data comes back from that URL, and that becomes the data that gets passed into the template. So if I were to update the template from this to this on the About page, no callbacks, no selectors, no DOM manipulations, not really a notion of a document at all. And we could do that for the same for the favorites route. So assume we've implemented a route for favorites here, and we're fetching data from API current user favorites. Some API comes back. We can update the template to this, and we can loop through it. So that's basically the basics of an Ember app. It's very simple to put together. We have hidden the abstraction of the DOM. Obviously, we're still using the document object model beneath to handle rendering, but that's an implementation detail you don't need to worry about. We could, in fact, swap it out for a canvas if you decided that we want to do canvas drawing, or SVG if you decided, like, I need to write an application that scales massively. Let's use SVG. So that's a cool basic demo, but let's do something more interesting. What about a real application? One of my favorite things to do now that I've gotten good at writing sort of rich client UIs in the browser is to take an existing application that is not written in Ember. This one happens to be written in Backbone, and reverse engineer it into how I would structure it in an Ember application. So let's walk through roughly how I'd architect an app like Rdio. Everyone familiar with Rdio, music playing application? If not, just think, it's like iTunes, but it runs on the web. So we're going to walk through a series of these interactions. When you first crack open Rdio, can you see the tiny little spinner? I know the resolution or the contrast on these is pretty low. You first get a spinner, transitions from that into this. So the main area at the top loads, some navigation on the side, and a little bit on the bottom. So roughly, this is pretty much how I would implement that in Ember. An app, an empty router for now, and two templates. One's the application one, where I'm going to say, I'm going to put content in here later. And then I would implement a loading route, which we'll actually swap in as the display automatically for you. So that's the loading route. Some data comes back from the server. And then this is what we transition to, where we've loaded the main part of the screen, and now the loading state has moved into the smaller section of the screen. So taking a look at some of the things that we've set up. So this is the HTML with the handlebars as you would do it. So these are links to additional parts of the site. And then in the playlist section, for example, with the data returned from fetching playlists, I would loop through each playlist and then link to the particular playlist. And this is how that data connects between the two. Up in the top, you have another div with some link tos going to my profile account and some message alerts. And again, this is how it connects to the data that's come back from the model hook and the route. And then finally, we have an outlet. And this basically says we're going to fill that with more content later, which puts us at this screen. RDU transitions into this screen eventually. So here I'm extending our application from this to this. So I've added a new heavy rotation route. And all that does, again, routes are responsible for fetching data. Fetches some data, so it goes to API heavy rotation. This is the screen. We've already loaded the loading template. Some data is returned from the server, and then we render this. So here's the HTML markup of what I would imagine this would look like. Just have a header with heavy rotation, loop through each of the items returned from the model hook, showing title, artist name, song count, and if it's explicit, an explicit tag. And again, this is the data that comes back and how they connect together. Next interaction, seeing navigation, or navigating to an album. You click on an album, you transition to the loading state, which will handle for you automatically. And then finally, you see this. So how would we do it? We'd take our existing application, loading temp, oops, sorry. Here I've implemented a album route. The rest of the application is sort of off screen for the sake of fitting it. And this album route, again, routes are for data fetching. Just goes to the API using $AJAX and fetches more data for us. Loading template automatically applied, some data is returned, and then this loads. So what about data routes that are nested? So far I've just used a sort of single layer of hierarchy with the outer application layout and then the inner part. Yeah, it turns out we can handle that pretty easily with routing as well. So for example, let me go back. When you click on an artist, this part of the screen goes white, and then when you end up with this, automatically showing the albums. If you click on songs, just that part of the screen goes to loading, and now you're showing songs, and so on. So in code, it would look something like this. We would extend our router to have an artist resource, and then some additional things inside of it, like albums and songs. We would implement an artist route, which fetches the artist, an albums route, which fetches the albums for that artist, and then this loads. Oops, there we go. Transitioning to that, and now we see this. If you click on songs, you get the loading screen automatically, and then it transitions to this biography, et cetera, et cetera. So it's basically this is the pattern over and over and over again. So playback. How would we handle playback? So what I want to do is be able to click on, knock louder, and then have that song begin playing. So this is our initial application template with just the single outlet. So basically saying, here's a single place I would like to put additional content at a later time. We can have multiple outlets. You can define ahead of time multiple places you would like to insert dynamic content based on user interaction. It does require a little bit of extra code. So here's the default behavior of the application route. In this case, because I would like to do two different things in rendering, not just one, I need to implement render template and override its behavior of calling super, which will fill the main outlet normally. And then also I want to render a play bar into the application template into the outlet called play bar. So that gets our play bar rendered. And if we click something to start playing, we need to now trigger an event. So if you imagine this is how our tracks are set up. Each track's UL, LI, track number, and name. Pretty simple. I just add an action called play, and I'm passing this, which would be the individual track. And the way actions work, there's not event handlers in the way you would normally think about them. These semantic events, so play is a semantic event, will first hit the current controller where it can be handled. If not there, it'll walk up to the current route where it can be handled, all the way through the parent route, all the way up to application route, which allows you to handle play functionality sort of one place in your application, if you like. So I'm going to put play on the application route here, and I'm just going to say, grab the controller for play bar, and then send this action called play. And here I'm going to implement now the play bar controller and an action called play. And inside that, I would probably access a HTML5 audio template, or if I need to use Flash as a fallback, that's where I would fall back to Flash. And because we put it in a single place in the application, in fact, all the various places that you can do playback in an Ember application are handled in this one piece of code. No document selectors, no event handlers, just solid semantics about application behavior. So that is all the slides I have. I like to leave a lot of time for questions because there's usually a good amount of them. So I think we have about 10 minutes for questions. Any questions? Yay, nay?
So what is the best way to start on a lower state of one of these systems? There's a lot of similarity with Rails. And what is the best resource that you can use?
So the question was, what is the best resource for getting started with something like this? And a lot of that will depend on your skill level. If you've done iOS development, maybe just the guides. So we have a fairly extensive getting started guide that'll walk you through building the To-Do MVC application. I don't know if you guys are familiar with this one, but it's a sort of reference implementation of an application built in many frameworks. Oh, yes, you can't see my screen. Thank you. Go ahead and mirror the displays at this point. So that's the To-Do MVC application. So that's a sort of a reference app. If you go to MVC.com, it's been implemented in all the modern JavaScript frameworks, and so you can take a look and see what the differences are between them. Other than that, Code School has a really cool Ember course, nice and guided. I believe you can get the first lesson or two for free. It's like, I don't know, then you buy a monthly subscription after that. Good places to get started. Yes?
So I noticed the more complex the application gets, like RDO, for example, it's a pretty complex application. You've got things like the default load handler, so it'll show the screen or whatever.
Yep.
But what about all the error state, right? Maybe the application gets some more error states you have to handle other things. How do you do that? Think about that.
So the question was, as the application becomes more complex, we've handled things like the loading state, but not necessarily error handling. I just didn't demo the error handling. Whoops. Ember.js. Take a look at our routing guide. Somewhere in here we talk about the error handling. And it's part of the loading and error substates. So the similar loading behavior we also have error handling capability. So we will handle errors in that way. Yes?
If I need to change my JSON into count conversions, I can return it directly to the model. Is there sort of a pattern?
So the question was, is it just like you have the format of the JSON is different than what you need in the application?
Right.
So the question was, if the JSON that's being returned from the server isn't quite so nice that you can directly dump it into a template, are there patterns for doing that? There are several large libraries. I mean, one, you could just use something like underscore to map through and do something to turn it into the format you like. There's a library called Ember Data, which is sort of a full ORM style application. There's another one called Ember Model, which both of these are maintained by people on the core team. They're sort of competing ones. Ember Data is probably the more robust but more complicated. Ember Model is less complicated but probably supports less situations. Ember EPF. And then there's this one, Ember Persistence Foundation, which is probably the most complicated, but probably handles the most number of use cases. And this is all around, the person who wrote this wrote an application that's highly transaction-based. So he needs to do things like manage change sets so that he can send data, and if the data is changed by someone else, send back a conflict and show exactly the diff between the two. And this supports that semantics out of the box. So there's a number of solutions for it. Probably your best bet, like if you just want to get started, is like in the model hook, just map, like loop over the things and map to what you want, basically. Return from that a new base object, basically. Other questions? Yes?
What do you see as core teams' biggest upcoming changes to the framework?
Oh, excellent question. The question was, what do I see as the core team's biggest upcoming changes to the framework? So we're pretty serious about semantic versioning. So we hit 1.0 the last day of August last year, which seems much longer ago. And our promise is to not have backward breaking changes. But we do have a lot of cool new things coming in 2014. Let's see if I can find the blog post where we talk about them. Well, all right, we don't really have, can't find the blog post. Does anyone see it off the top of their head? Let me just Google for it. Ember 2014. Hey, look at that. Google's better than a website. So a lot of big initiatives. So internally, Ember's been around for about 3 years. At the time, there were not really good module formats. Well, that's not true. There were good module formats. There were just too many of them, and we did not want to even get involved in a Vim Emacs-style holy war about which module format was most appropriate for the browser. So everything sort of hangs off the global Ember namespace, which means internally, if you want to figure out where a bit of code lives, good luck. So we just actually finished the work of converting all the modules to ES6 style modules. So ES6 modules are coming in the next version of ECMAScript, which is the non Java owned version of JavaScript, and that can be transpiled from that format using some really awesome tools in Node, which will generate the abstract syntax tree for us and allow us to recombine it into ES5 compatible JavaScript. So we convert it from ES6 into AMD right now, but we could also support CommonJS, which means as you develop Ember applications, you'll be able to pick just the specific parts you need for your application, which is cool. So right now, Ember is like 65 or 70K as a dependency. In the future, it will be exactly as large as the bits you need. You don't get much better than that. Probably the other coolest thing we have going on, well, the Ember Inspector is pretty awesome, and we'll continue to make cool changes to that. HTML bars is probably the biggest change. Right now we use handlebars for templating, and HTML bars is a drop-in replacement for handlebars. Actually sits on top of the same runtime, just compiles down to handlebars runtime compatible code. But instead of emitting strings and doing DOM templating with strings, we'll actually be doing DOM templating with document fragments, which is much, much faster. We're hoping for like a 2 to 10x depending on your use case, and totally backwards compatible. So one of the nice things about adopting a tool or a widely used framework is we'll launch this work hopefully April or May sometime, and every Ember application that updates will instantly be 2 to 10 times faster for view rendering with no work on the developer's part. So those are probably the other ones. You had a question over there? The question was, what do you use to test the different pieces of an Ember app? Ember itself so we happen to use QUnit. So a lot of our testing stuff right now is tied to QUnit just because that tends to be what the community is using. There's a lot of work to make that more generic so you'll be able to use it with any testing framework you want. We have some really cool test helpers. There we go. So for integration tests, we have nice integration helpers. So you can visit particular URLs, click on things. It looks like this basically. So visit a particular URL, fill in the stuff, click the thing with the selector, and then after a while, I should see this data. And then unit testing is just basically QUnit, make a new object, do some things to it, assert that the object is in the shape that you like. Other questions? Yes?
So you opened this talk with the transition from the browser being a document viewer to being like an app runtime. You equated it to progressing towards native app quality. So clearly when you talk about native app quality, a big concern is performance, right? And not Ember specific, like be as general as you can.
Yep.
Obviously, different browsers have different performance characteristics.
Yep.
I mean, you showed this on Spider Test for IE, for example. What as developers that we're approaching these kinds of frameworks, what can we do to help level the playing field on performance when there's a black magic going on behind it that we can't see?
So the question was, I'll distill that down. On the topic of performance, what can people do to help level the playing field so that if you find, for example, IE10 is slow, how do you jump in and make that happen? We're very serious about performance. We have 2 people on the core team who basically do nothing but look for performance flaws. So actually part of the HTML bars rewrite, it's really a rewrite of our entire view layer. They're basically going through the Chrome stack frame, like frame by frame, looking for milliseconds, and doing the same with Firefox. IE testing is a little harder because there's not great developer tools. So it's basically like they just look and see how fast things roughly feel. So like, how would you jump down and do it? The Chrome debugger is probably the best thing. So if you find performance problems with Ember, I think we would, maybe your particular usage of it, it may be a problem in the framework. Either way, file a bug, and we can tell you like, oh, this just happens to be, the way you're using it is not performant, or it's a serious bug and like, we'll fix it internally and you'll get performance upgrades. Other questions?
You had shown radio or whatever it's called. That's backbone. Are there any big things using Ember?
Oh, good question. The question was, I showed RDO, and that is a backbone application. Are there any big apps using Ember? Google again, see if I can find it. There's some big companies using Ember that we list on the website. We've been compiling a list of, give it one more shot. Dang, how could I not find this? It's in, I'm always nervous about jumping in and showing personal, oh, this is especially bad because that's my work account. Dang, there's a big list. I guess I'll just name some of them. Vine, Vine's web presence is all Ember. Zendesk, their customer service application is all Ember. Nest uses Ember, so if you use the web interface for the Nest thermostats, that's all Ember. Square, if you ever log into their dashboard to check the finances, that's all Ember. NBCnews.com is all Ember. Yeah, no, there are a lot of major applications from large companies that have adopted it. There's a whole list somewhere. We're compiling a list to do sort of the like, strap. I forget what it is. There's a site that's basically like a curated list of applications that are using Bootstrap, and it's a similar thing. We want to show those. Yes.
Tying on to that, what do you like as larger open source apps that are good to look at? I know there's Discourse and Travis.
Yep. So the question was for larger open source applications, which is a great learning resource, right? You can see a production application, and you don't just see the fake demo I give. You see all the warts. Yes, the three big ones that I can think of, Discourse, which is from Jeff Atwood, who does Stack Overflow as well, is an open source discussion forum. Back end in Rails, I think, front end in Ember. Travis CI, which I always do as travis.ci, even though that's not it. Travis CI's front end. Oh, so if you use the Ember inspector, the Chrome plugin, you get a little Ember icon. And you can see, as you browse the web, what applications you hit that happen to be Ember applications, and can browse through like the routes and see what current route you're in. And then there's another company called Billy's Billings. They're like a finance and billing application, but they release a ton of their stuff open source. In fact, their whole platform is. So they're very much in the like, give it away for free, charge for hosting and manage. And their entire UI is also Ember. So those are probably the three big ones. Other questions in the last 2 minutes? Cool. Well, I'll be around afterwards if you'd like to chat with me personally. And thank you very much.